I'll introduce Ricardo Magna, who's been a project manager for more than 10 years in Europe, North America, South America. He's been a project manager professional since 2007. He also holds, so these are, if you're a project manager, you'll understand what these mean. Scrum, Prince 2 and IPMA certifications. He has a Bachelor of Control and Automation Engineering with postgraduate work in project management and MBA. He's doing research for PhD at University of Auckland, exploring the fundamental system of production in construction. So the concept of buildings being assembled by production systems could be something quite interesting. All yours, Ricardo.
Oh, thank you very much. I'm right on time. Yeah, seems to work. So, first, thank you for your time. And the idea here is how can we understand the production system inside projects. Manufacturing already developed some techniques, theories, and some ideas that support the production. They have a very steady production, but we quite mess around in projects. It's pretty much all that.
Vader, this is an unexpected pleasure. We're honored by your presence.
You may dispense with the pleasantries, Commander. I'm here to put you back on schedule.
I assure you, Lord Vader, my men are working as fast as we can.
Perhaps I can find ways to move it.
I tell you that this station will be operational as planned.
The Emperor does not share your optimistic appraisal of the situation.
But he asked the impossible. I need more men.
Then perhaps you can tell him when he arrives.
The Emperor's coming here?
That is correct, Commander. And he is most displeased with your apparent lack of progress.
We shall double our efforts.
I hope so, Commander, for your sake. The Emperor is not as forgiving as I am.
Yeah, we know how to do it slower. This dialogue is about velocity. Is it possible to speed up projects? I mean, forget about the additional resources. Can we make it faster? And I say yes, we can. Vote for me, yeah. It's not my fault. Our projects usually are slower in the beginning, and somewhere in time we kind of find a way to work with, and we can accelerate this project. The problem is that this dynamics, when you go speed up your project, it's not concerns only your project. You have to consider the whole supply chain. Well, I heard about the problem with supply chain getting materials here in New Zealand. My example is the World Trade Center, the new one, that it requires a special kind of concrete. It's a 16 psi concrete with this compressive strength, and it was produced by only one supplier in Brooklyn. So, if you need to speed up this project, can the concrete maker do the same at the same pace? If the supply cannot keep it, you're going to stop. You have to wait for your supplier. So how can I model and can we understand this dynamics of production mostly in repetitive construction projects, and how can I use this approach to manage the project? We came up with only 2 requirements. It has to be an analytical solution. I don't want a very complex simulations around it. I want a formula, not very beautiful. It doesn't need to be like that. And it has to be practical. I don't want to spend 1 month to estimate one activity. And it has to be applied to both big projects and small projects. The idea, the base of this framework, is the production knowledge in manufacturing. So we have tried to see what's the common links between productions in projects and in manufacturing, and then use it to translate. The first idea is, what's the project? Oh, I have my client there. He has, she has his operation, and by some some reason he needs to change it. Can be a property developer that needs some more real estate to sell, or maybe the transport agency that needs to expand his network transport system. And so he doesn't know, he doesn't care about A to B. He wants to be in the stage B as soon as he can. So he hires a specialist that we're going to solve his problems with, obviously, a teleporter, because I want to go very fast. I don't care about A to B, I want to be on B. So I get my operation inside the machine, is there, I pay you, and we done. Unfortunately, we cannot do that now. So we have to work together in strategies from A to B. And this is a compilation of about 10 frameworks and methodologies from different industries, from oil and construction, even consulting is in there. And it involves 2 major stages: think and do. In this order, don't think after you do. Think first. And you have, for this system to study, we have 3 stages. The feasibility, that's all what I'm going to build. I cannot build a teleporter, so what's the solution for my transportation across the harbor? Is it a tunnel? Is it a tagline? Is it a bridge? What is it? So how am I going to do it? I need to understand. Can I use BIM to design that? Yes, why not? And finally, I'm going to build. I'm going to construct the whole thing. So this is your state transition from A to B. How does it occur? We have our teleporter, yes, that transports us from a state operation to another one. Steady state, it's when several properties, in this case in production, are invariant over time. Yes, and in manufacturing you're expected to produce a very steady amount of telephones a day, every day. But we don't do that in projects. We use the same approach, but over time. And that's not true either. We don't produce the same every day. So why can we expect that for a lot of workers? Maybe there's some project that we have 5,000 workers. How can we expect that? So we have some changes in velocity in this project. And projects involve learning curves. Therefore, altering this relation of output-input over time, those are characteristics of a steady-state system. And there is a lot of non-linearities in there. The production run. I have 2 main production runs. The one is the short production run. Nice car, I did myself. We have the short run. The amount of production in short run is fixed and known since the beginning. What enables a better planning and equal cost distribution. So if you know what you're going to build, you know the exact amounts. $1 million for each unit, you know very well how much is the cost for any units that you have to be produced. And you have the long run. In manufacturing, we have some how many units you can produce. There's some laws, but the final element you don't know. It's just an estimation. So we have the event termination of these runs. On projects, your opportunities for improvement are restricted. Lessons learned from deliverables that you already did in the past are readily applied into a project, unless it's a very similar project or it's a very close project, in time, I mean. Because sometimes you created a stone sheet bridge 10 years ago. So lessons learned going. In manufacturing, you benefit from this kind of thing. You can do it, for instance, if you have an iPhone and you have the iPhone 5, you come up with a solution that can reduce the price of the cost of this screen for $1 after the final run of this font that's not being produced anymore. You can make about $100 million of it, because that's the run of it. So how can I transform a project? Can I translate a project in manufacturing like? This is the Freedom Tower, One Trade Center. You can see the whole video in the back of my business card. There is around there. And so you have one activity: install Windows. Oh, you're gonna make estimation for install Windows? Okay, 2 years. Not very good. So how about I can do it more manufacturing-like? Maybe I can manage by floors. I have 100 floors. Oh, even better, I can track every single window there. So the window installation on the 100 floor is supposedly to be faster than 90 floors below, because they repeat this process over 20,000 times over. So by now they know how to install it. But maybe you can ask me, so how about the wind? The wind up there is way stronger than on the initial floors. But then on the 100 floor, the wind is not that much stronger than it was in the 90 or 89 or so they are learning how to do that, to work with the wind and the installation, so they work faster. What impact? The speed, the uncertainty. Uncertainty is the concept I'm using is a concept that came from economics over about 100 years ago or more. It's a potential, unpredictable, unmeasurable, and uncontrollable outcome. The risk that we use in our project is a consequence of an action taken over uncertainty. For instance, imagine these two guys, and they are about to skydive from the airplane to a target on the ground, but there's only one parachute. So at this point, the level of uncertainty experienced by the man is equal. Is the parachute going to open or not? But at the moment that just one jumps, he takes all the risks. The uncertainty is the same. Is going to parachute open? Is the window blowing away? But it doesn't affect the guy in the plane. It doesn't matter. Oh, with the time passing, the parachute opens. This uncertainty goes away, but there is still some impacts of the wind. If the wind deviates the guy from the target, this difference is the variability. So how this concept apply to our projects? This is it's called the concept of uncertainty. It was developed by Microsoft a few years ago, and this is an estimation error in your project. That's for software development. You have a huge uncertainty when you start your project, because actually you don't know what you're going to do, and then you take some decisions that take this uncertainty away from your project, and the design phase until you complete your project. There is nothing else to happen anymore. For construction, you can take the same shape, but it impacts the costs in the project in a manner that you can. All the uncertainty, all the risks you take are also opportunities. So if you come up with a decision that can save you costs, take it earlier, because after the project's done, it's done. So how does it look like? How does framework look like? Okay, we have our two stages, A, B. I have my main thinking phases that are there, that generate a lot of uncertainty. I have my risk management stuff that's going to take some decisions about what can impact my project, or what should I take as an opportunity. By risk management, we are talking about expected value and something that considers money. Dawn is not that, what's the risk here? Yellow ball, no, blue ball, no. It doesn't solve anything. It has to be concerned about money and impact there. So, what we cannot filter, we're going to impact our projects, causing variability. It can be good or bad. So, what's the things about the framework? I'm proposing a model to, instead of avoid this variability that should be done on risk, to understand it and go to management side. You can use it as a management tool. How does it work? It's basically, I guess what I'm just using a process there. I know the input function and I know the output function. I can get some mathematical relations, it's a convolution between two functions, and create a model for this prediction. So, does it work? This is an example. It came from a paper, published paper. It's not my data yet. And there's a plan for a productivity plan. It considers a variable number of workers during every week, and they differ in production just by the end. They have different production rates. That was the plan. That's the real thing. Not even close. It's only explained 11% of what actually happened. So is there a better way to do that? Yeah, there is. I got the productivity that they use it to every week, and multiply by the actual number of workers. So I came up with a better estimation of 41%. That's not good enough. Using the method that to obtain the transfer function, I tried the same, and I came up with an explanation of 75%. So I jumped from 11 to 75% in accuracy of my prediction, to predict my prediction. The real thing here, it's the difference between the production estimation and the transfer function is the transfer function takes into account every movement. This is not an instantaneous change. It's a, can you increase your production by doubling your efforts in a certain time? Can you do it? What the value you can get from there? So yeah, it was a nice thing. It's on the very beginning of its development, but it proved to be analytical. It's a formula there. Actually, there are two polynomials there. It's practical. It took about 50 minutes to come up with that estimation. Well, I jumped from 11% to 75% in accuracy. Now that I know the speed of my production, I can use it to synchronize, to tell my suppliers, oh, I'm going to need like 3 times more raw material by the 7th week. And I can improve my logistics by there. Maybe you have to import things, and you have to work on this time that you need your raw material here. And as you don't need to go the market looking for these raw materials like crazy, you can reduce your cost and plan your purchase.
The Death Star will be completed on schedule.
You've done well, Lord Vader.
So we are about to collect data. We have some partners in Europe and America as well, South and North America, and we're going to try this on every kind of repetitive construction. So if you're interested to take part of it, please call me, send a mail, or something like that. Thank you very much.
Any questions for Ricardo before he helps me put the computers back the way they were?
Hi, Ricardo. My question, well, I don't know if it's a good question, but I'll try. What is the importance of, what are the implications of this model, this production model in New Zealand construction sector and in New Zealand in general? Why would this make a difference? And in cases, for instance, like Christchurch, explore a bit.
Okay, I can think in at least two possibilities. The first one, you can coordinate well, we have to import a lot of raw materials, okay, from overseas, and it takes time. So you can, if you know the speed of your production, first thing you can control the activities that it's subsequent to that one, and you can plan your requirements, your purchase from overseas. So, okay, I can reduce the speed for, maybe I don't have concrete now, I can reduce the quantity of this concrete until we get time to import. This can be one of the approach there.
Yeah, and what in comparison to other models, what is what pose different specific to?
Yeah, usually what we do when you see our planning, you see this whole Gantt charts. It's a huge line, and that's not true. We don't work like that. There's a lot of uncertainty, a lot of variability taking place in our project. Usually we are very good to make it slower. But when you need to go faster, we cannot do it because, okay, I'm going to work overtime. But so, do you have the raw materials? Is there the raw material? Can you manage the supply chain? This is very useful. This guy uses something not the same thing, but the idea is the same from manufacturing. Or there's a new car coming on, a new model. Is there suppliers? Can we arrange a supply? Is there time to develop something to this new piece that you can use? It's probably it's something that we can think on. We heard about beam now. This kind of model can be introduced to beam. Yes. It's a formula.
Anything else? No? Okay. Thank you.
Thank you.